All right, so we know that with sine and cosine, we can find any points on a unit circle. But now we're going to try to extend that concept to be able to find points on any circle of radius r, where r is any number. Okay, could be 5, could be 10, could be 1/3. But we're gonna use this concept of sine and cosine in order to find the points on any circle of any size. All right, so we know that this point P, we know that the coordinates of that point P are going to be the cosine comma and the sine, right? So P is equal to cosine of theta comma sine theta. All right. Now, what if we want to find the coordinates of this point Q? Okay, what are their x and y coordinates? So the key idea here is that we've got similar triangles. All right. We know that, this angle, we got this, well, so let's mark this out. So we have this smaller triangle here, the one on the unit circle, right? We know that it has to be similar to this one. Maybe I'll mark it in red. This bigger triangle. You see this bigger triangle that goes out to Q? Right? It looks a lot like the one in the unit circle. It's just scaled up by some factor, right? It's a scale model. It's a similar triangle. Now, what factor is it scaled up by? Well, the radius of our unit circle was 1, and now the radius of this largest circle is r. So the scaling factor is just r. So that means we can scale all the sides up for Q. And so this point Q is going to be at r cosine theta and r sine theta, right? Because we can just scale the sides of the triangle here, this triangle that goes from the origin to Q and then down to the x-axis, right? It's just a scale model of this triangle that goes from the origin to P and down to the x-axis. Okay, it's a scale model, and the scaling factor is r, right? Because the radius was 1, and now the bigger triangle has a radius of r, which is the hypotenuse of the triangle. Okay, so it's just a scale model, and so we're scaling up all the sides by a factor of r. All right. So that's basically the result in this section, is that the point Q, the x and y coordinates of point Q, are just r times the cosine of theta and r times the sine of theta. Okay. All right. Now I gave you a little worksheet to do after the first exam, to look at these special right triangles, the 30, 60, 90, and the 45, 45, 90 triangle. Now, there are specific angles that on the unit circle that we can know the exact values of sine and cosine. Okay, and those are the 30-degree angle, the 45-degree angle, and the 60-degree angle. So let me draw a unit circle here and show you those angles. All right, so first of all, let's look at the 30-degree angle. All right, so you see the triangle in there. Now I've drawn an angle of 30 degrees. Let's pull out just that triangle, okay? So here's just that triangle, 30 degrees, so right triangle, right? Now if the radius is 1, then we know that this is a scale model of the 30, 60, 90 triangle. So remember the 30, 60, 90 triangle, I we usually draw it like this, 1, 2, square root 3. All right, the hypotenuse of the standard 30, 60, 90 triangle is a length of 2. But now we're on the unit circle, our radius is 1. Okay, so the hypotenuse is 1. Which means the scale factor is just a half. It's just half the size of the standard 1, 2, square root 3, 30, 60, 90 triangle. So this is 60, 30. Okay, right, this is the 30-degree angle up here. So I need to scale down all the sides by 1/2. Okay, so the short side, the side that's opposite of the 30 degrees, becomes 1/2. Right, I'm just taking half of it, and the long side the side adjacent to the 30-degree angle is the square root 3 over 2. Okay, so for the 30-60, or for, sorry, but for the 30-degree angle, the cosine of 30 degrees, right, is just going to be the x coordinate here, right? So it's going to be the square root 3 over 2. And the sine is going to be 1/2. Okay, these are important angles to know. Okay, so you want to keep these handy. You want to know these. All right, so the next angle that I'm going to look at is the 45-degree angle. So that's about right here. Okay, now it gets a little messy. I'm trying to put this on all on one circle. So let me try and draw this. Let's see, that's a 45-degree angle. Drop it down here, and now you can see this. Again, the radius is 1. Let me pull it out, though, so you can see it separately. That doesn't look like 45 degrees. Okay, let's say that's 45 degrees. The hypotenuse is 1. We have a right angle. And you know that the standard 45, 45, 90 triangle is 1, 1, square root 2. Those are the ratio of the sides. Okay, but in this case, the hypotenuse is the square root of 2. Here, this 45-degree angle, oops, 45 degree, not 40, 45-degree angle here. This is 45. It's kind of hard to draw it on here, but you get the idea. So it's an isosceles right triangle. When it's on the unit circles, the radius is always 1, right? So that's the hypotenuse. So we have to scale this down by 1 over the square root of 2, right? So this becomes 1 over square root of 2 and 1 over square root of 2. Okay. Now, you can also rationalize the denominator if you want to. Square root 2 over 2. This is equal square root 2 over 2. So I guess I tend to remember it. Square root 2, let me write that a little nicer. Square root 2 over 2. Square root 2 over 2, just because that's the way I learned it. Because back in my day we had to rationalize denominators. I'm fine with 1 over the square root of 2. So if you prefer 1 over the square root of 2, that's fine too. Just so you know that those are equivalent. Okay. All right. So we know that the cosine of 45 degrees is square root 2 over 2, and we know the sine of 45 degrees is square root 2 over 2. Okay. The last special angle that you need to know is the 60-degree angle. So let me draw the 30, 60, 90. Okay, I don't know how I'm. Again, I'm trying to pull out the, it's like here it might be 60 degrees, let's say. I don't know if that's not necessarily to scale here. But that's the 60-degree. Let's see, this is a 30-degree. This is the 45-degree angle. This is the 60-degree angle. Okay. If I pull out that triangle so that this is 60 degrees, hypotenuse is 1. 90-degree angle right here. Now, we have the 30, 60, 90 triangle over here, a little different orientation, but again, this is just scaled down by a factor of 1/2, right? Because in the standard 30, 60, 90 triangle, the hypotenuse was 2, now it's 1, so we just have to scale it down by a factor of 1/2, okay? The short side becomes 1/2 because it was 1, and then the longer side becomes square root 3 over 2. All right, so, again, the x-coordinate, which is the distance in the x direction, is 1/2. So that's the cosine of 60 degrees, is 1/2. And the sine is the y-coordinate, so it's this vertical distance here. So the sine of 60 degrees is the square root 3 over 2. All right, those are important to remember. Remember those. Now, under normal circumstances, you would have to have these memorized. There would be no question. They would be tested periodically and quizzed and drilled to know the sine and cosine of these angles, the exact values. All right, you would have to know these. Now, under the conditions we are now, I'm not sure. It seems like so much is online and it's just too easy for people to just, if you forget it, you look it up. And it's hard to police whether you've got a cheat sheet beside you to look up these values. So I guess, under pandemic conditions, I guess we're being a little bit more loose about having to memorize these. But these are important, important, important. The 30, 60, 90 and the 45, 90 triangles come up so often in real life that these are just really important to know. All right, well, that's all I have for you. And you should be ready to work on the discussion questions, and I'll see you in class.